In this video, we are looking at the second techniques used to solve nonlinear inequalities, and we are using or so-called the table method. To start off, we read off our question. It says determine the value of x such that x squared minus 2x is less than 15, right? So rule 1 states that we cannot multiply by an unknown variable. But here we don't have a fraction, so this rule does not apply. Rule 2 states that before we could solve this, we need to factorize. Before we could solve this, we need to determine for which values will this graph be equal to 0, because at that point it tells us where the graph changes signs. So we'll start off by applying the second rule. Firstly, we clean this up, x squared minus 2x, we send the 15 to the other side, minus 15 less than equal to 0, right? And then we apply the second rule, factorizing. We have x minus 5, x plus 3 less than equal to 0, right? So we factorized. How we use the table method is that we have these expressions, these brackets. So what you do, basically, you draw a table, right? You draw a table. You first write down your expressions, your brackets. We have the first x minus 1 bracket. We have the second bracket, which is x plus 3 bracket, right? And the reason being we are drawing this, you want to determine the impact of your zeros. Do you agree that if we solve for values of x, that's the second rule, it asks us to solve for which values of x? This is 0. So we know from solving this, if we could just solve it, we would have x equals 5. We would also have x equals minus 3, right? Those are the 0 points. And then how we use this relative to the table is that we basically draw a number line just beneath the table. Just beneath the table, you draw the number line, right? And these points, they represent the zeros or the roots or the x values where the graph is 0. Here we have minus 3, right? And we have 5. And what we want to do is we want to determine, because we said we already know it's a fact, as previously shown in that example, that if we draw the graph of this thing, at these points where the graph is 0, that this thing changes signs. So now what we will do is we will see what happens, what's the effect of these graphs just in between. How are these factors, x minus 5 and x plus 3, how are these impacted by values in between the zeros? So for values, let's say less than minus 3, right? Let's say we take, for argument's sake, a value of minus 4. Let's take a value of minus 4, right? If we take a value of minus 4, we plug it in here, right? We'll have minus 4, minus 5, and then we have minus 9, right? So minus 9 is just a negative value, so we'll put a negative here. So we want to see what's the effect of the sign, right? And then we take minus 4 as well here. So minus 4 plus 3 is minus. So whatever value we take that's less than minus 3, this will be a negative value, because minus 4 plus 3 is negative 1. And if you take any values further than that, this will always be negative for any values less than 3. So for this expression, we will always get a negative value. But now let's see at what happens between minus 3 and 5. Let's take any value, let's say for argument's sake 1, because 1 is just between minus 3 and 5. So we put 1 now here. So 1 minus 4 is negative. So for values between minus 3 and 5, for this expression, we will get a negative value. However, for values between minus 3 and 5, for which in this case we took 1. For this expression, 1 plus 3 is 4, so this value will always be positive, right? Now for values greater than 5, let's take for argument's sake 6, right? And we plug this value here, so 6 minus 5 is 1, right? So, and 1 is positive, so we'll always get a positive value. And then if we take 6 here, 6 plus 3 is 9, and 9 is positive, right? So now you'll get to see why we use this, right? So we see here we are multiplying these expressions, right? We are multiplying them. So we want to see that for which values will this be negative, right? So if we multiply, do you see we're looking at this expression and this expression? So, and here we're multiplying them. So if you multiply a negative and a negative, we get a positive, right? Here, if we multiply a negative and a positive, we get a negative. And here, if we multiply a positive and a positive, we get a positive. So, but this thing, we know that any value less than 0 is negative. So, in other words, the question is asking for which values of x will this graph be negative? And we can see that this thing here, for these values, it will be positive. For these values, it will be positive. But for values between -3 and 5, this will be negative. So just to quickly write it down, so we'll just say x is just between between 5 and -3. That's where this thing will be negative. So this is the answer. Do you see we get to the same answer as we did with the graphical method?